Last time we did a little refactoring of the code so that we could start making AI characters with the code we have already written for our player character, just to be efficient about things, right? So that's what we're going to be doing here today. We're going to be making a separate blueprint for it. Theoretically speaking, that's not actually needed, but we're going to do that. So the way we will easily do that is we'll just duplicate the blueprint for the player, and we'll rename that to blueprint enemy instead. And when we open that up, and then we can go into its class defaults and we can change its parent class around. So we have the base player character for our player, but instead we're going to be using the base enemy character class that we have made. So far, both of those classes don't actually have any code specific to them. They're both just the base magic character class that we have made. And there's a good chance it's actually not going to end up having too much code in either of them, because the main difference between the two of them is going to come from their controllers. Our player controller, which we have made up in the last number of parts, and the AI controller and behavior tree that we're going to be making going forward. I do want to change the material. So now we have an enemy wizard. It's a wonderful material, by the way. Whoever made this, props to you. Now, selecting the topmost thing here for the BP enemy, we can go in and check its controller, and its default AI controller will be the just AI controller class. And we're going to make a specific class just for this. We're actually not going to, interestingly enough, put too much code in that, because the code that's going to drive the behavior for this character is going to come from its behavior tree more so than its actual controller directly. And you will see what that means in a second. We also want to see auto possess for the player should be disabled, and auto possess AI should be placed in the world or spawned in the world. So that way, whether or not we spawn something in through maybe a different enemy dying spawns this enemy, or whether we just place it into the map, it will always get auto possessed by the AI. So let's get to making a new C++ class here. We'll go all classes and we'll make an AI controller. We'll call this base enemy controller, which once again is not going to house too much code to begin with, but we'll figure it out. This is going to have a couple of variables though, and a begin play, which I'm just going to copy over from one of my other classes because it's always the same, and we'll create a definition for it. And as you might recall from earlier in the tutorial series, sometimes you get these weird little errors. We just reveal our U project in the Explorer and generate Visual Studio project files, and you just sometimes need to do that. It's annoying. Anyway, in our base enemy controller, in our begin play, what we're going to do is we're going to run a behavior tree, and that needs a U behavior tree pointer. And that's going to live on our base enemy character on the header file. So here we'll make a U property, edit defaults only, or edit anywhere. I'm going to go with edit defaults only for now. And that is going to be a U behavior tree pointer, which we'll call the BT asset. And you're going to likely need to forward declare this as a class. Going back into our controller here, we need a reference to that. So what we're going to do is we're going to first and foremost include our base enemy character. And we're going to try to make a base enemy character, which will be our enemy variable here. And as we're probably used to by now, we're going to try to cast that to an A base enemy character. And the thing we're going to get cast here is going to be the pawn that we are possessing. If that is successful, then we will run the behavior tree. And the behavior tree that we will run will be the behavior tree that we just put onto that enemy. So BT asset. You also probably want to check whether that BT asset is valid as well in that if statement. It's inaccessible though, because I am an idiot and didn't make a public section here. And by default, everything is private. So let's make that public. And now we can compile that and we can start making our basic AI. I have a basic series on Blueprint AIs as well. And for the most part, it's not going to change too much for C++. So we're going to go through this relatively quickly, hopefully. Going back into our blueprint for our enemy, we can now see we have, if we delete the search, we have a BT asset slot. So let's make a behavior tree, shall we? We also probably need to start organizing things a little bit better, but I will do that some of the time. If we go up into artificial intelligence, we can make a behavior tree, and let's call that BT basic enemy. And that will be the behavior tree that we use on this enemy. Behavior trees are, in essence, a collection of paths that a character can follow based on certain conditions given. So we have the root. This is where the behavior tree will always start, and when a path is completed, it will reset to the root and choose a new path. And from there, we have selectors, we have sequences, and we have simple parallels. I do believe most of these will be relatively self-explanatory. The simple parallel is doing two tasks or two subtrees, really, potentially, in parallel. Honestly, I don't often use these. The sequence will do anything you put under it in a sequence, so it will do one task and then the other and then the other and then the other. When a sequence is started, usually you don't break whatever it does the entire thing, and then it moves on, like resetting or whatever. And the most important one that we're going to be working with here is the selector, because the selector will select one of the things beneath it, where the sequence just does everything that is linked up to it, under it. The selector will choose one of the things that it is hooked up to. So let's say we have 2 or 3 sequences. By default, what it will do is, and I will try to zoom in a little bit more, I can't zoom in more than this. Hopefully you'll be able to see that these things all have these little orbs with numbers on them. And this is the priority order. So coming from the root into the selector, that's 0. Well, then the selector will choose the thing with the lowest number priority. So it will choose 1, and if that's for whatever reason unavailable, it will choose 2, and then it will choose 3. This automatically just picks the leftmost thing. You can see if I choose the sequence to be put here, that becomes 1, and if I put that sequence all the way over there, this becomes 1. It just goes from left to right. So as it stands right now, whatever happens, it's always going to go root, selector, this sequence. Whatever we put into these two sequences is never going to get triggered. What we can do is we can add a decorator to it. So let's say we want to have a tag cooldown. This means that whenever this executes or fails to execute, whenever this is just selected, it will lock itself for, in this case, 5 seconds. We can also say 90 seconds, which means that the next time we're coming through here, it will check this, it sees, oh, it's still locked, and then sequence number 2 will be played instead. And there is a bunch of those selectors, as you could see. The most basic one is the blackboard selector, and that is because a behavior tree always requires a blackboard to be linked to it. And the blackboard is kind of like the header file for the behavior tree, where it houses all the variables that fit within whatever behavior tree we are building. So let's make one of those as well. We can right click on this. We can simply go into the artificial intelligence and make a blackboard as well. And usually just for organizational purposes, I like to just always make these in pairs. Sometimes you can reuse a blackboard for multiple different behavior trees. That's fine, that works. I like to just make them in pairs. It's a little bit less optimized, theoretically speaking, but in any practical terms, it's really not that big a deal. So with none of these nodes selected, if we go into our details panel here, behavior tree, we can set our blackboard asset to the blackboard we just made. And now this submenu over here opens up where we can put in our variables. And it also shows all the variables, or the keys as they're called, in a blackboard over here on the bottom right side. So if we go and add a decorator for a blackboard decorator to this sequence, we can now see we can choose a key to query. We can choose a blackboard key. In this case, that would be self-actor, but we can also make a bool like can shoot, just like any normal variable. And there we can say only if isShoot is set, which means that it would be set to being true, would we do whatever is in this sequence. Otherwise, it will move on to here. But what if we end up with a situation where can shoot is set to being false, and it moves on to this sequence, but while this sequence is executing, can shoot changes its value. Or the other way around, maybe we say can shoot is set to true, and while the sequence is being executed, it changes and it should no longer be allowed to shoot. That is where we come into this notify observer and the observer abort. By default, the abort is set to none, but we can also set it to only abort itself. So whenever the outcome of this bool changes, it will stop doing whatever it was doing in this branch of the behavior tree. We can also say you shouldn't abort yourself, but when you see, hey, something else is happening in another side of the behavior tree and I am now suddenly able to do my thing, stop whatever those other branches were doing and do my branch. Or you can say both, which is cancel this branch when it's no longer allowed to be active, and also cancel other branches when I again am allowed to become active. That entirely becomes usually relevant when you add a very, very important node, which is the wait node. This just pauses the whole behavior tree for the amount of time you put in here. So you put in a wait time and a random deviation. So if I put in 5 and 1, it will wait 5 seconds plus or minus 1 second. So it will wait for 4 to 6 seconds, which is real nice. So that's basically how behavior trees work in general. Now, we have a lot of these tasks that we can do, right? There's a few that are pre-made here, like make noise, which is good for the perception system that Unreal gives you. You have move directly toward or move to. You can play an animation. You can play a sound. You can push a pawn action. You can rotate to face a blackboard entry. You can run behavior dynamic, run a query, set a cooldown tag. You can wait, or you can wait blackboard time. Those are all pre-made things that we're not all going to be looking into right now, but those are pre-made tasks. You can make your own tasks as well. If you come up here, you can make a new task, a new decorator. So you can also make your own decorators if you want to check whether or not something specific in your programming would allow or disallow a certain thing. You can make your own decorators that will allow or disallow branches of your tree to happen. And then we also have services. I want to talk about services a little bit before we start getting into making our behavior tree. Services you can put on any of these nodes as well. So we can add a service, and these have not that many default ones, but if we say default focus, we can set that. And the default focus is the thing that our enemy actor will be looking toward. That's just something that Unreal has pre-built for us, which is very, very nice. We can, of course, make a task for that. We can make a task to say, hey, default focus should be set to the player character. But things that need to run without being like the endpoint of your behavior tree, things that might also influence the status of some of these keys that can then influence how the behavior tree runs, all that kind of stuff. You can put those in the services, which means that whenever we go through this selector node, this service will also run. So whenever we go through the selector node, now our Blackboard key for self actor will be set to the default focus. Now let's make a object here for our player instead. And then if you make a object key, that's kind of annoying. What you want to do is you want to open up this key type, and then the base class, we want to change that to actor in this case, because we specifically want it to look at an actor. It can't just look at any object. So we can set the default focus here now to the player, and anytime we go through this selector, the default focus will get set to the player. Meaning that if we, for whatever reason, anywhere else in the behavior tree, like in a node in here, set the focus to something else, whenever the tree resets, it will reset it back to the player, which is very, very nice. Other things that you can use this for is creating a node that sets a key on here, for instance, with the distance to the player. So you have a reference to the player, you have reference to the enemy itself, it calculates the distance and sets that to one of these keys. And then you can make a Blackboard condition that instead of using this bool here, we can make one float distance to player. And you will see if we change the Blackboard key from this bool that we've been using to a float, the queries also change. And now we can check whether or not this distance is equal to, or not equal to, or less than or equal to, or greater than or equal to. So let's say if our distance is less than a certain number, let's say 1,000, or actually let's say 1,500, that is when we want to shoot. I think we're going to leave it there for right now. This is the basics of how AI behavior trees work in Unreal. These are all the separate little bits of information that you need to know. If you are very used to working in Unreal already with blueprints, you probably know most of this already. So next time we're going to get into actually making a service. Maybe we're going to make a custom decorator. I don't think we will have to, honestly. And we're going to make a custom task to allow the actual shooting of a bullet from the enemy. But for now, this has been the introduction to behavior trees. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. And a special thanks to my Cave Digger tier Patreons, Sir J. Thomas,